Thank you. So today we're talking about congruent triangles. I suspect we'll probably finish this and we can make a start on similar triangles this lesson, although I don't think I'll teach it, because I think the stuff we're doing with similar triangles is stuff we sort of done in Year 9, and it just requires a bit of problem solving. So let's get straight into congruent triangles here. We've listed the 4 ways in which you can know that a triangle is congruent. And what does a congruent triangle mean? It means they've got the same size. So it means that all sides are the same size and all respective angles are the same angle. They could be different orientations, okay, which means one could be twisted and the other one could be at a different angle as well, different rotation. So we've got, if all sides are the same, then it's congruent. If we have a side and an angle in between them, and then another side that's the same, if we have 2 angles and one corresponding side, that means it's in the same relative position to the 2 angles. And for right angled triangles, if the hypotenuse and one side is equal, it means the remaining side is equal. And so we have all 3 sides are equal. So let's demonstrate a proof. Okay, we're asked to prove that triangle ABC is congruent with triangle ABD. And I'll introduce some terminology to you here as well, some notation. Firstly, we're told that AB equals CD. All right, that this side and this side are equal. That's what that notation means. And remember I said everything we write we need to provide a justification for. And our justification here is that that's what's given to us. We're told that. All right, it's given to us in the diagram. And in the same manner, AD equals BC. That is also given. All right, so we've got 2 sides that are the same. It's not. There's no right angle there. It's a parallelogram. So we can't use the right-hand side justification. But this side here, AC, is what we call common. It's common to both sides, which means AC exists in both triangles. All right? That distance is the length of this triangle, and that distance there is the length of this triangle. And so it's common. And so we have 2 sides that are equal and one side that is shared. So we're going to write it like this: triangle ABC. All right. And the way we write congruent is we draw like a squiggly line like this, and then equals underneath it. All right. So it means equal to, with similar angles, triangle ADC. And so we're saying they're congruent. This is how we know it's congruent. And so the method through which we know it's congruent is that side, side, side. We have 3 sides in common. And so you can see we've justified it with the first theorem of congruent triangles. Okay, so we'll have others using the subsequent proofs there as well. Let's have a look at the second example. Now here we're told AB is parallel to DE. So that means they're going in the same direction. And we've got BC equals CD. Those 2 lengths are the same. And we're asked to prove that BD bisects AE. So length BD is this one here. Okay? And if it bisects it, that means that that length there and that length there are going to be equal. It means it cuts it straight down the middle. So we need to prove that AC equals CE. We need to prove that they're the same size. And so what we'll do is we'll prove that they're congruent triangles, and we're going to say that those sides correspond. So firstly, we can see, we've got triangle ABC and triangle CDE, we can see that BC equals CD. That's given to us. Okay, so we have one side in common so far. Okay. Next, let's do something like this. Let's let angle ABC equal alpha. All right. Remember, I've said we can sort of do that thing. We can just make up some shorthand notation so that we can label that on our diagram. Now, okay, what we've got here, these are parallel lines. So I'm going to sketch it like this so you can sort of see what's going on. This is kind of the shape we've got, isn't it? Okay, where these lines are parallel. And so what that means, if this angle's alpha, okay, it means this angle here is also going to be alpha because they're alternate angles in parallel lines. So that means we have, therefore, angle CDE is also alpha. Okay? Alternate angles in parallel lines. All right. And then we're just going to do the same for this remaining angle. Like there's, I'm looking at this and going, there's so many ways we could possibly take this to prove it. But let's just go, let angle BAC, let's let that equal beta. So this is beta. Then what's the alternate angle with this one? It's going to be this angle up here. Okay, let's provide a justification. Therefore, angle, and we'll call that DEC. Again, for the same reason. All right, and I want to point out a third way how we know that's true is that this angle, okay, ECD, and this angle are equal because they're vertically opposite one another. Okay, so we know they're equal, and so we've already identified first that those two are equal, which means this remaining angle has to be equal as well. So you can see how it's all related. So we have here angle, angle, and a corresponding side being equal to one another. So we know that these triangles are congruent. So we're going to say that. Therefore, triangle ABC is congruent with triangle CDE. Now I'm going to describe it like this: DEC. So it's got the same shape. And the justification: angle, angle, corresponding side. So we've got beta corresponds with beta, alpha corresponds with alpha, and this side here, CD, corresponds with side BC. So we have two angles in common and a corresponding side in the same relative position. So they're congruent, all right? Now, because they're congruent, it means all sides are the same. And so therefore, AC equals CE. And so we've proved it. Therefore, this length BC, BD, therefore BD bisects AE. Alright, because this length and this length are equal, because they're congruent triangles, this length here is going to cut it straight down the middle. So we'll see how you go with some of these questions. We're starting to lay out some formal arguments here, some formal proofs. Let's give it a crack, see how we go with it. There's not too many questions there.